So we're going to look at designing a pole tent with a floating center pole with some of the new MPanel tools. We'll start out by just drawing in a regular pole tent, and I'll just move that into a slightly isometric view to where we can see, for instance, the center pole, which is of course a 3D poly. I'll just color it magenta for ease of reference. It will first of all just make a conventional pole tent by relaxing this, and it's usually best with pole tents to relax as a cable-edged mesh, and that's saying that there will be some stiffness, some strength in the hips, and you can see that with the default settings we get a very strong pull-in, a very strong tension on the hips there, and it may well be that you would choose a different shaping, and the hip cables are affected by the left and right cable tension settings, so just reducing those, and we'll now get a pole tent which is perhaps more the kind of shape which you might be used to designing. Just making it clear that the cables which run down the hips here may actually be webbing, or they may actually be just the stiffness of a lace line, or the stiffness of multiple layers of fabric sewn or welded together along those hips. Now let's say that we want to allow the center pole to float, and we're going to let it float up and down in Z, that is in this direction, and we're going to support it with 4 cables, one from each corner. We'll draw those cables in initially as lines. So there's the first 2. And there are the next 2, and again for ease of reference we'll colour those lines green. Like so. And we'll now put a poly constraint onto this center pole. So I'll select the center pole, go to Model Builder Tools, Polyfloat Constraints, and I'll set a constraint on it that will allow movement in the Z-axis, and that will allow this pole to float up and down and find a natural force balance. I'll set that float on the poly and receive a report back that the poly tag is set to float Z on that poly line. We can now go in and relax this again, making sure that in our option settings that the line is going to be read as a guy link, that is a stiff link, and it will have a link stiffness. I'm going to use 100 as the initial link stiffness. Now when I select that model and relax it again with the cable edged mesh, we end up with a model. We'll look at this just in front view, where the guys have stretched and developed tension down at the bottom, the stiff links have stretched, and the pole has sunk down to accommodate that, and of course the shape of the whole structure has now changed. It may well be that you want the center pole to sink down less than this, and would achieve that by putting more tension into the guys, and would get more tension into the guys by setting them to a higher stiffness, to where as they stretched more they would have a higher tension developed in them. It needs a little bit of care, because as we go up to higher and higher stiffness values, the model will become slower to relax, that is, it will need more iterations to relax fully. So I'll go ahead and relax that model with the higher stiffness, and you can see that the cables have tightened, But with just 250 iterations, which is what we have set at the moment, this is not necessarily fully relaxed, and with high link stiffnesses we should always check by relaxing the model again to see if there is any further movement. And we can either continue that process until there is no further movement, or we can set a much higher number in here for the maximum iterations. Once we're happy with both the shape of the tent, the structure, and with the amount of droop on the cables in here, then we could look at the tensions that are being generated in those links. Typically we'll find that those tensions are much higher if we go for a small drop in the pole position. We would obtain the tensions through the new report tool, pre-stress link tension report, and in the options for that we have to set a value for the pre-stress in the fabric. I've set here 50 pounds per foot. We're doing this drawing in Imperial, and you just put in a value there which is the expected value for the pre-stress in the fabric. Having done that, we can select the model and run the report. And we'll obtain a report here which shows us both the tensions in the bottom guys, here shown as 2,163 pounds, and also the tensions in the cable or webbing or stiff seam running up on the hips there. Of course, MPanel is not an engineering package. To get real accurate figures, particularly for load cases, we would use MPanel FEA, but this gives a good basis for making engineering decisions about the structural sizes required